Hello students, in this session we shall discuss the polynomial chapter of class 9 maths. Now we shall recall algebraic expression which we have done in the previous classes. See, if I write 2x or 3y square plus 2 z square minus 5z plus 3. See, these are the algebraic expression I have written. Already you have got. In algebraic expression, what you have learned? See, there are these x, y, z are the variables. These are the letters of the English alphabet, and these are considered to be the variables. And 2, 3, minus 5, these are the constants of the polynomials. Now, in 2x, it can be written as 2 into x. Actually, these are in the multiplication relation. 2x means 2 into x. So now in 2x, you see this x is the variable and this 2 is the coefficient of x. And in 3, y square plus 2. So it can be written as 3 into y square plus 2. So coefficient of y square is 3. This is the constant associated with this variable are called the coefficients, and these are these are in the multiplication or division relation with the variables. Similarly, in this z square, that means coefficient is 1. You can write 1 into z square plus minus 5 into z plus 3. So clearly you see the coefficient of z square is 1, coefficient of z is minus 5, and 3 is the constant term. So these are called the polynomials. These algebraic expressions are called the polynomials. So you have learned the coefficients of the polynomials. If I write say 2 minus 5, 3, these are the constant polynomials. These are called the constant polynomials. So actually the variable with the associated with these numbers, the exponents of the variables are 0. Say 2, so its variable is actually 2 into x to the power 0. So by the laws of exponent, you know the value of x to the power 0 is 1. So 2 into 1 is 2. This is minus 5 and minus 2. These are called the constant polynomial. And if we write 0, this is called the 0 polynomial. So these are the polynomials. These algebraic expressions are called the polynomials. But these algebraic expression 1 by x, if I write 1 by x or root y plus y, or say cube root of z plus 3, these are not considered to be the polynomials. These algebraic expressions are not considered to be the polynomials. Why? Because 1 by x we can write x to the power minus 1 by laws of exponents. This we can write y to the power 1 by 2 plus y. This z to the power 1 by 3 plus 3. Now see in this terms, in these expressions, the exponents of the variables are negative and fraction. In this case, this is negative, and in these two cases, these are fraction. Exponents of the variables are fractions, you see, and this is negative. So if negative and fraction exponents are there in an expression, in an algebraic expression, if the exponents of the variables are negative and fraction, these are not considered to be the polynomials. Remember this. Now, terms of a polynomial. So first we have written 2x. Now see, 2 and x, these are in the multiplication relation, if and these considered to be a single term. So 2x, a single term. If it is single term or one term, then these are called monomials. And if I write the second polynomial 3y square plus 2, See, there are two terms, but how can you determine that two terms or three terms or more terms? Remember, always terms are determined by the addition and subtraction sign, plus or minus sign. See, in these expressions, here in between z square and 5z minus sign is there, and 5z, and in between 5z and 3 there are the plus sign is there. So this, if plus and minus sign is there, then these two terms are considered to be the separate terms. So actually there are three terms and there are two terms. But if we consider 3y square, 3 is multiplied by y square. So this will not be a separate term. This as a whole it is a single term. This we can determine. Now there are clearly there are two terms and there are three terms. If two terms are there, then these polynomials are called binomials. And if three terms are there, they are called trinomials. Alright. This way we can find the terms of the polynomial. Now if I write a random polynomial, say x square minus 2x plus 3. Now see, this is the polynomial. The whole expression is called the polynomial, and this x square minus 2x and 3, these are the terms of the polynomial. There are three terms. This is trinomial. If it is more than three terms, in general these are called four terms or five terms. So in general these are called the polynomials. So these terms of these polynomials are x square. Second term is minus 2x. You have to take the symbol minus, and third term is the 3. This is the constant term. So these are the terms of the polynomials. Now we shall learn the degree of a polynomial. So again we shall consider these polynomials. 2x. If I consider 2x, see, degree, how can we find the degree? Degree is the highest power or exponent of a variable in a polynomial. Degree is the highest power or exponent of a variable in a polynomial. So variable is x in this polynomial, and what is the power or exponent? Here is 1. So degree of this polynomial will be 1. If we consider second, 3y square plus 2. So here variable is y square, y, and the exponent is highest power or exponent in this expression or in this polynomial is 2. So degree of this polynomial is 2. Again we shall consider another polynomial, say z cube minus z plus 1. So here the highest polynomial is 3. So degree is 3. This you have to remember. These are called the degree of the polynomial. Now if I consider the constant polynomial, say 2 or minus 3 or 5, these are the constant polynomials, and degree of the constant polynomial is always 0. Degree of all these are 0. Why? Because 2 can be written as 2 into x to the power 0. Similarly minus 3 and minus 5 also can be written like this. So here you see the exponent or power of the variable is 0. So degree is 0. This way. Now depending on the degree, we can determine, say if I write 2x plus 3, suppose a polynomial. So here the degree of this polynomial is 1. So these are called actually linear polynomial. These are the actually types of polynomials. These are called linear polynomial. Now if I write 3y square plus y plus 2, so degree is 2. Degree of this polynomial is 2. So these are actually quadratic polynomial. If I write x cube minus x square plus 3, these are called cubic polynomial, as the degree of this polynomial is 3. So this way we find the polynomial, determine the types of the polynomials. Now we shall see that 0 of the polynomial. zeros. What are zeros of a polynomial? See, you can see the variables in a polynomial. Every polynomial has a variable, or these the value of this the particular value of this variable for which the value of this polynomial is 0. I repeat, the particular value of these variables for this the value of a particular polynomial is 0. These are called those values are called the zeros of the polynomial. So consider, if we consider say x plus simple, I am showing a simple polynomial, say x plus 3. This is a linear polynomial, and as the degree is 1. So what is with the 0? 0 means the value of this variable, the particular value of this variable for which the value of the whole polynomial is 0. So what would be the value? You can by looking at this expression we can find we can determine this should be 0 equal to minus 3, definitely, because if I put minus 3 here, then minus 3 plus 3 equal to 0. See, the value of the polynomial becomes 0. So 0 here, in case of 0 is nothing but the value of that variable, the say x, y, z, this. So these are called the 0. So for linear polynomial there is one and only 0. For quadratic polynomial, these there will be 2 zeros. 2 zeros may be equal, but there will be 2 zeros. And for cubic there will be should be 3 zeros, this way. So in this exercise we considered the linear polynomial, mostly with the linear polynomials. So these are called the zeros of the polynomials. So I am just showing an illustration from the example, from the exercise 2.2. you see here I am showing. You can refer your textbook. Say number 3. In number 3, you see, verify whether the following are the zeros of the polynomial indicated against them. So if we consider number 1, see, it is given 3x plus 1 and value of x is minus 1 by 3. So given x equal to minus 1 by 3. So therefore p, we have to put this value in place of x. So p 1 by 3 will be equal to 3 into 3x, that is 3 into 1 by x. So 3 into 1 by minus 3 plus 1. After simplifying, we got the result is 0. See, p minus 1 by 3 is 0. After putting this value of x in this polynomial, we got the value is 0. So we can now we can say that this value is the 0 of this polynomial. Therefore minus 1 by 3 is the 0 of the polynomial of the given polynomial. If you are given two values, in number 3 you are given two values, so you have to show it separately. See, I am showing. Number 3 I am showing. You are given p x equal to x square minus 1, or x equal to 1 comma minus 1. So therefore first we shall consider p1. Let's see what is the value of p1. So we have to put 1 in place of x. So it is 1 square minus 1. So ultimately 1 minus 1 0. So p1 we have got 0. Next p minus 1. So minus 1 whole square minus 1. So square of the minus 1 is again 1. So 1 minus 1 0. See, in both the cases the values of the polynomial are 0. So 1 comma minus 1, sorry, both 1 comma minus 1 are the zeros of the given polynomial. This way we have to verify the zeros of the polynomials. So you can do the rest. Next I am showing number 4. You see, find the zero of the polynomial in each of the following cases. In number 3, the zeros are given. We have to verify. Now the polynomials are given and we have to find the zero. Let's see the number 1. See, here it is given, you see in your book, px equal to x plus 5. This is the given polynomial. So how can we find the zero? Let us consider px equal to 0, because the 0 already I have discussed, the 0 of the particular value of the variable for which the value of the polynomial must become 0. So I have assumed this px equal to 0. So value of px is given x plus 5 equal to 0. Now we can solve it, and after solving we have got x equal to minus 5. Alright, so this minus 5 is the zero of the polynomial, given polynomial. Therefore minus 5 is the required zero. Now I hope you can understand, and you can do the exercise 2.1, 2.2. These are very easy.